Good afternoon all. Let's see what is Hadoop Distributed File System. Hadoop Distributed File System can be referred to as HDFS, and we know what a distributed file system design is. Distributed file system design means the files or the file system is not stored at a single or at a single server or not at a single location. It is the files are stored in multiple file servers or in multiple locations. So Hadoop file system is developed using the concept distributed file system design, and HDFS is run on a commodity hardware. Commodity hardware means a device or a device component which is quite inexpensive and also widely available. So it is run on a commodity hardware, and it is not like any other distributed systems. HDFS is highly fault tolerant, and also it is designed using low cost hardware. Now, as we told, to store such huge amount of data, files are stored across multiple machines, and it can handle very large amount of data, and also it will provide easier access to these data also. And all these files in HDFS is stored in a redundant fashion. Redundant fashion means there can be any chances of failure and also data losses, so it can recover easily from these kind of failures. So it is stored in a redundant fashion, and it will also allow applications to use those data for their parallel processing. And to use HDFS, Hadoop provides a command interface also. Now let's see the features of HDFS. The first one is data replication. Data replication means all this data in HDFS is stored inside nodes. We'll see what node is in the coming slides. So it is stored in nodes, and if the node crashes or there occurs any failure, the HDFS will always keep a copy or a replication of this data, so that when such failures occurs, it can easily use the replicated copy, so that no process is getting discontinued, so the data will be easily recovered also. Then comes fault tolerance and reliability. Because of the data replication feature, we can of course say HDFS provides fault tolerance and reliability also. Then high availability. Data is always available even if the name node or a data node fails. We'll see what name node and data node is in the coming slides. So no matter if these name node or data node fails, the replicated copy will be always available. And then comes scalability. Scalability means a cluster will store different type of data in its nodes. So as the user's requirements increase, a cluster can accommodate more than hundreds of nodes, more than 100 or hundreds of nodes in its cluster. So that's scalability. And then comes data locality. Data locality means data nodes. Normally this data will have to be taken to the computation unit for its computation. Like computation unit will be in some other place and data will be in some other places. But here the data and the computation unit is both placed in the data node. So you can minimize the distance between the data and the computing process. So this in turn will decrease the network congestion, and also it will boost the system's overall throughput also. So that's data locality. Then high throughput. We told in HDFS data is stored in a distributed manner, so that the data can be used for parallel processing on a cluster of nodes. We told data is stored in distributed manner, so data can be used for multiple processes for their parallel processing. So this feature plus the feature we told data locality, this will both ensure high throughput in HDFS Then this is the basic structure or basic architecture of HDFS. You can see there is a name node at the center and data nodes below them. As seen in the figure, HDFS follows a master slave architecture, and also it actually supports a traditional hierarchical file organization. It means the user, as we do in our systems, the user can create, remove, rename or move files from one directory to another. Now let's see the main components of this architecture: the name node, data node, etc. So the first one is name node. Name node is actually a commodity hardware. We discussed what is commodity hardware. So it is a commodity hardware that will contain an operating system and also a software. The operating system is usually the Linux OS, and the software is that of name node. It is a name node software, and it will also perform some other tasks, like it will manage the file system namespace, and it will regulate the client's access to the files, and if there are any changes to the namespace or its properties, name node will record that also. And there are certain operations like closing and opening files, directories. So all these file system operations will also be executed by name node. Then comes data node. Data node is also a commodity hardware which will also have the Linux OS and the data node software combined in it, and this is the main node that manages all the data storage of this system, of this entire system, and it will perform all the operations related to read write operations as per the client's request. And also it will perform the operations like block creation, deletion and replication according to the instructions of the name node. So the instructions will be given by the name node. Then comes block. In HDFS, all the user data that is given will be stored inside files, and all these files will be divided into different segments, and these file segments are called as blocks. Or if we say it in another words, block is the minimum amount of data that HDFS can read or write, and the default block size is always 64 MB, but if there is any changes required in the configuration of HDFS, then this default block size can be extended or increased. Then let's see what are the goals of HDFS. The first one is fault detection and recovery. We told HDFS uses a large number of commodity hardware, so we can expect failure of these components often. So to overcome these failure, there should be always some best mechanisms to overcome this failure. That is fault detection and recovery. Then huge data sets. Huge data set means HDFS should have hundreds of nodes per cluster to manage the applications having huge data sets. HDFS should have each cluster of HDFS should have hundreds of nodes, so that only then it can manage the applications which are having very huge data. Then comes cost effectiveness. We told it is run on a commodity hardware. Commodity hardware means which is inexpensive. It means it is actually cutting off the storage cost. So by this feature it ensures cost effectiveness. Then comes large data set storage. HDFS can store a wide variety of data which is of any size, like it can be from megabytes to petabytes, and also the data can be in any format, like it can be structured or unstructured data. Then fast recovery from hardware failure. HDFS is designed in such a manner that it can detect the errors fast, and hardware failures also. Then comes portability. HDFS is portable across all hardware platforms, and also it is compatible with different operating systems like Windows, Linux, Mac OS, etc. Now HDFS use cases and examples. Let's see where HDFS is actually used. HDFS is used by Yahoo in its company's online ad placement, means the location where an ad should be placed in a website. So Yahoo uses HDFS for its company's online ad placement and also for some other requirements of its search engine. Now, likewise, many other companies like eBay, Facebook, LinkedIn, and Twitter also uses HDFS for the same purpose. And HDFS has got some other applications also. It is used by the New York Times as part of their large-scale image conversions, and HDFS is used by Media 6 Degrees for their log processing and machine learning, and then LiveBit is using HDFS for log storage and odds analysis. Likewise, many other companies are also using HDFS to manage their pools of big data. So that's all about the topic. Thank you.